So I think the 3 points that I really tried to drive home until now are, to get neural networks to work well, you require these 3 essentials. You require a large data set, a varied data set, and a real data set. And if you have those capabilities, you can actually train neural networks and make them work very well. And so why is Tesla in such a unique and interesting position to really get all these 3 essentials right? And the answer to that, of course, is the fleet. We can really source data from it and make our neural network systems work extremely well. So let me take you through a concrete example of, for example, making the object detector work better, to give you a sense of how we develop these neural networks, how we iterate on them, and how we actually get them to work over time. So object detection is something we care a lot about. We'd like to put bounding boxes around, say, the cars and the objects here, because we need to track them and we need to understand how they might move around. So again, we might ask human annotators to give us some annotations for these, and humans might go in and might tell you that, OK, those patterns over there are cars and bicycles and so on. And you can train your neural network on this. But if you're not careful, the neural network will make mispredictions in some cases. So as an example, if we stumble by a car like this that has a bike on the back of it, then the neural network actually, when I joined, would actually create 2 detections. It would create a car detection and a bicycle detection. And that's actually kind of correct, because I guess both of those objects actually exist. But for the purposes of the controller and the planner downstream, you really don't want to deal with the fact that this bicycle can go with the car. The truth is that that bike is attached to that car, so in terms of like just objects on the road, there's a single object, a single car. And so what you'd like to do now is you'd like to just potentially annotate lots of those images as this is just a single car. So the process that we go through internally in the team is that we take this image, or a few images that show this pattern, and we have a mechanism, a machine learning mechanism, by which we can ask the fleet to source us examples that look like that. And the fleet might respond with images that contain those patterns. So as an example, these 6 images might come from the fleet. They all contain bikes on backs of cars. And we would go in and we would annotate all those as just a single car. And then the performance of that detector actually improves. And the network internally understands that, hey, when the bike is just attached to the car, that's actually just a single car. And it can learn that given enough examples. And that's how we've sort of fixed that problem. I will mention that I talk quite a bit about sourcing data from the fleet. I just want to make a quick point that we've designed this from the beginning with privacy in mind, and all the data that we use for training is anonymized. Now, the fleet doesn't just respond with bicycles on backs of cars. We look for lots of things all the time. So, for example, we look for boats, and the fleet can respond with boats. We look for construction sites, and the fleet can send us lots of construction sites from across the world. We look for even slightly more rare cases. So, for example, finding debris on the road is pretty important to us. So these are examples of images that have streamed to us from the fleet that show tires, cones, plastic bags, and things like that. If we can source these at scale, we can annotate them correctly, and the neural network can learn how to deal with them in the world. Here's another example. Animals, of course, also a very rare occurrence, an event, but we want the neural network to really understand what's going on here, that these are animals, and we want to deal with that correctly. So to summarize, the process by which we iterate on neural network predictions looks something like this. We start with a seed data set that was potentially sourced at random. We annotate that data set, and then we train neural networks on that data set and put that in the car. And then we have mechanisms by which we notice inaccuracies in the car when this detector may be misbehaving. So for example, if we detect that the neural network might be uncertain, or if we detect that, or if there's a driver intervention on any of those settings, we can create this trigger infrastructure that sends us data of those inaccuracies. And so, for example, if we don't perform very well on lane line detection on tunnels, then we can notice that there's a problem in tunnels. That image would enter our unit tests, so we can verify that we've actually fixing the problem over time. But now what you do is, to fix this inaccuracy, you need to source many more examples that look like that. So we ask the fleet to please send us many more tunnels, and then we label all those tunnels correctly. We incorporate that into the training set, and we retrain the network, redeploy, and iterate the cycle over and over again. And so we refer to this iterative process by which we improve these predictions as the data engine. So iteratively deploying something, potentially in shadow mode, sourcing inaccuracies, and incorporating them into the training set over and over again. And we do this basically for all the predictions of these neural networks.